All right, guys. So I'm gonna do one more video uh, before that sample project comes out next month. But it is next month, isn't it? Yeah, June. So it's supposed to come out in June. So you'll notice that like my forward stop transition looked pretty good, and my back one looked pretty good, and that one actually didn't look bad either. But you'll notice that my one to the right and my one to the left, it's very lacking in quality. Uh, and sometimes it'll look okay, but it really depends on the pose when you move over into the stop database. And I'm going to explain that all to you guys as best I can. So it is a little confusing. And I have mine split up into starts, stops, loops, pivots. And then I have an idle one that I have as a backup, but this one should never fire. I have the idles and the starts and the stops, and I probably could have combined those two into one, but that's just how I decided to do it. So anyway, I might combine them later into one, but it was easier for me to have an is stopping and an is starting. But I obviously could have done a true on both of these, but then there's no way to say this or that. So, oh, I could have made a variable actually. Yeah, I could have made a variable that was true if this or that. But anyway, that's beyond the scope of this and beyond the point, really. So I'll go ahead and explain to you the problem. So whenever I was leaving my loop database and I was moving into the stop database, the last animation that was played in the loops was getting stuck, and it was sticking inside of that one loop animation after moving over into the stop database. And the reason why is because of the continuation cost. So the continuation cost of staying in that animation and continuing playing it was lower than uh, it would have been to play one of the stop animations. And so I'm going to explain that to you. So if you've watched some of my other videos, then you'll know that I had predicted that it may be slightly problematic whenever you're setting up a regular game animation system with regular game ready animations with motion matching, because you can't actually use root motion from everything because you don't have enough animation to cover all the different trajectories. And so because of that, your character movement settings actually plays a crucial role in the post search selection process, and I can prove that. So the trajectory cost is affected by your acceleration, your max walk speed, and your braking deceleration speed, and everything in between. Everything that affects those three values, including ground friction, braking friction factor, braking friction, um, all of that has a direct effect on the pose search and how well it can score uh, poses from that database based on your trajectory and your movement settings. So to prove that, let me come in here. Now I called this speed, but these are actually pictures that were based on the braking deceleration walking. And so these are the different braking deceleration walking speeds that I tested this against. And I'll go ahead and show you. So I started off with a braking deceleration walking speed of 300, and I was getting stuck, and this is what I was talking about right here. So right now In this frame, I'm actually in the stop database, which has no jog writes or looping animations or any of that. But you'll see that these are each 2 frames in to the stop database. So after it switched over to the stop database, I went 1 frame forward just as a safety precaution. Also because these didn't show up on the first frame. So you'll see that right now I'm in the stop database, but I'm still playing the jog right animation. And that's because the continuation cost is 0.002, whereas the cost to move into the jog right stop, the lowest cost for frame 1, let's see, at time 0, I guess, yeah, would be 35.997, which is pretty high. So the trajectory cost is 32 and the pose cost is 3. But you'll see that the forward right stop actually has a lower pose cost, but it has a higher trajectory cost because it's moving in a different direction. But the pose matches closer than that of the right stop. So that tells me 2 things. If this was a one-off, then you could explain it away. But it's not a one-off, and I can prove it because I tested it at different speeds. So if I move over, whenever I would increase my braking deceleration walking speed from 300, when I increased it from 300 to 500, what happened was the trajectory cost significantly dropped. It dropped to 8.237. So I kept going. I kept bouncing around, and actually I wasn't slowly increasing it. I was bouncing around using a kind of an exhaustive method. So I went to 1200, and you'll see that it dropped down to 2. The trajectory cost was 0.778. The pose cost was 1.3. So the pose cost wasn't actually matching that well. And the reason why, and I wish I would have taken full screen pictures, but the reason why is because, well, let me just go ahead and show it to you guys. So I've already kind of set this up so I could show you. So let me just dock these so that we have more real estate here. So this is the first frame of the stop animation for the jog forward stop, and this is the jog forward loop. So and I wish they wouldn't have done this. I mean, it's kind of cool that we can still see this, but I wish we could trigger it to stay in place or to move in space. Whenever used to in 5.3, whenever you would force root lock or enable root motion, it would lock it in place, and he wouldn't actually move through space. Now he does. Maybe they'll put it back like that later. I don't know. But anyway, it's a slight annoyance. But you'll see that, well, depending on the foot. So if I'm on let's see, if I'm in this pose right here, whenever, and you'll see they're both on their left feet right now. If I'm on this pose right here, then I have a better chance of the search database choosing this pose right here. And it may be that it would probably choose it somewhere, something like that, more likely. But the point is that if he's on this foot, then the pose cost to move into this frame of the animation is going to be significantly higher due to a higher pose cost because these poses don't match. So that's why your pose cost can affect the actual overall cost right here. And the PCA cost, I'm still not really 100% sure exactly what that is, but I'll get back to you guys on that later. It's not really the important thing to take away from this. But so I kept moving around to different speeds, and you'll see I got it down to 0.249. And then right here, I got it down to 0.206. And then right here, I got it down to 0.126. And then at 950, 1.26. So I chose a speed in between 940 and 950. And that's what I went with. So if you look over here, you'll see that my braking deceleration to walking speed is 945, and that's the reason why. That was the speed that gave me the lowest trajectory cost for the stopping animations. So I say that because I want it to be painfully clear to you guys that the character movement settings does have a direct effect on the outcome. So that's one thing. Also, there's this offset root bone, and they are going to have this. They're going to be making use of this in the sample project. They're changing the translation mode and the rotation mode dynamically. I'm not. My settings over here are different than theirs as well. I was experimenting. In the live video, they only show the first 3 settings. They don't show the rest, and they don't show you how they're deciding the mode. But accumulate or interpolate seems to work best. But I have a feeling that, like, during specific situations, like turning in and running the opposite direction, might require this to be set to hold or release. So I'm not going to go in depth on this setup, but I'm not using any variables. I just dropped this over into here and I set these values. It doesn't really require much more effort than that, other than maybe managing the translation and rotation modes. But I currently don't know how to properly do that because I've not seen an example of that. So I'm not going to pretend like I fully understand it. Now I am using the steering node, and I do have it set up properly. I'll go ahead and show you guys how that works. So if you watch the live video, you'll see that that they had the Loco Blend stack. Oh, they had theirs named to something different, but they had this anim node reference right here, and it confused me at first because it was the first time I'd ever seen that. But come to find out, I figured it out. All you have to do is add a tag to one of these nodes, and this actually works on the main anim graph too. So you can add a tag to just about anything. See, they have these tags, and if you add a tag on that, then you can actually right click and type in that tag, Loco, and it'll show up as a node reference. Loco Blend Stack. That's the one for this one right here. See, I named that one Loco Blend Stack, and then this one is named Loco Blend Stack 2. And then you just click that, and there you go. You have your reference. And so what this is doing is with this reference to this blend stack input right here, since you can't cache poses inside of here, you have to use this method. And so you can get the current blend stack anim asset, and you can get the blend stack anim asset time for the current anim asset and the anim asset time. And then your steering target time, it's just a static variable, and they're only making it a variable because they're using the same value as the procedural target enum time, the enum target time, and I've unexposed the target time, which is exposed by default. And then we're also using it for the get desired facing direction. Now on theirs, they were working on setting up some kind of branch system, but he wasn't finished with it at the time that he did that live video. And all I'm doing is I'm just getting a reference to the trajectory off of the character reference. I'm not getting the reference to the trajectory directly. Don't do that. I've tried doing it, and it seems to give incorrect results if you try to directly reference it. But after you've gotten the character trajectory and you've went in there and selected your trajectory, then you can get the trajectory sample at time, and that sample time is 0.4 seconds into the future. So it'll get the facing direction that it predicts the character will be facing a fourth of a second into the future. So it's a prediction, and that's what we're using as the target orientation. So, I mean, that's basically it. That's the rundown on what I've learned. But between the steering and actually, I'm not even sure that I actually need the steering because I think that's mostly for a forward-facing animation system, not a strafing left to right system. So in actuality, I think they're actually disabling this whenever he's in the strafing, and he's enabling it whenever he's in the facing forward setup because he has both. He has setups for both of those types of animation modes. In mine, I have it turned on, but in actuality, like I said, it probably wouldn't be turned on in a strafing system. But then he's using the offset root bone, and that's how he's getting that smooth interpolation to prevent it from snapping from moving right to moving forward. And so if you were wondering how I got it to kind of smoothly interpolate right there, that's partially the reason. That and orientation warping. Yeah, so you'll see that it's kind of jittering now, and that's because I was in there playing with those values. Actually, that might be because I disconnected the steering. I didn't think I needed steering, but maybe I do. It may be that he's turning steering on and off at certain during certain situations. Maybe if the angle becomes too much, then he needs to turn it off. Actually, that seems to be the case because now it's working fine. But you'll see. Let's see. Well, there's been a few cases where I've seen the feet do funny things, and I'm wondering if maybe that's when he needs to turn it off. Yeah. So yeah, right there. Yeah. So anyway, that's basically the rundown on it, guys. I just wanted to show you that proof that I had that the movement component settings actually have a very big impact on your cost bias. And if your cost bias is too high, when you enter inside of one of these, when your chooser switches from the looping to the stops, if the cost bias is too high because your capsule movement settings aren't reflecting accurately the animations in the database, then it'll cause the cost biases inside of all the animations inside of this database, or just some of them, to be too high, and so it won't choose the correct one, or it simply won't choose one at all. It'll continue playing. It'll continue playing that pose within that one animation from the last database that you left. Anyway, that's basically all I got for you guys. That's all I've learned so far. I hope this is helpful. But I figured since I don't that I'm not aware of any videos that have covered any of this stuff or anybody else that has discovered this. So I thought I'd go ahead and do a video on it. I'll see you guys in the next video.